All right, this is a condensed version of what we would have done in class today on absolute value equations and inequalities. So there's some general rules that we need to go over about what this actually is talking about. So there are two types of problems we're going to be solving today. Absolute value equations, which have an equal sign, and absolute value inequalities, which have less than or greater than, less than or equal to, or greater than or equal to. So essentially what we're looking at is if you have an absolute value of an argument, which we're just going to call it x, and it's equal to a positive number on the other side, then there are two ways that this could have played out. The interior of this argument could have either been a positive of this number or a negative, because if you say the absolute value of 3, everyone reports that as 3. If we say the absolute value of -3, everyone reports that as +3, because absolute value measures your distance from your center, or for us, normally that's the 0 on the number line. So for us, we're going to say that we're going to call this positive number a. We're going to say that x could have either equaled positive a inside, or x could have equaled a negative a inside. A lot of people misconstrue this as we're dropping the absolute values. We're not. We're saying the inside of the absolute value could have either been the positive of this number or the negative of this number. If your absolute value is equal to a negative a on this side, that is no solution, because there is no way that a number can have its absolute value become out to be a negative, because it's measuring distance. The only way you could have that is if you had a negative symbol in front of the absolute value. So if you just have your isolated absolute value and it's equal to a negative, it is a no solution case. So for the equations, this is our scenario. We have either you're going to be setting up two different equations to solve, or it's going to not make sense and you're going to have no solution. For the inequalities, there are 4 cases. Now, we are just looking at strictly less than and greater than. If you add in the equal to, it just makes it have a bracket on the answer. It's not really changing the way we solve it. So if we talk about, and this will be our first case for the inequalities, if we say that we have our absolute value of an x is less than a positive a, some number, we could have that our absolute value is less than a negative number, a. We could have that an absolute value isolated is greater than a positive a. And we could have that the absolute value of a value x or some kind of expression is greater than a negative a. Cases 1 and 3 are actually something you can solve. Case 2 and 4 are special conditions. So let's first talk about this. For our absolute value to be less than positive a, that means that we have to have a distance that is smaller than the a distance. Now, if you're at x in the middle and you say this is a 2, to be smaller than that, you can't step more than 2 to the right or 2 to the left. So we actually squeeze the x in between negative a and a. So it becomes an in-between situation when you have this. That is analogous to and. Anytime you see less than, it's an and problem. And problems have what we call these compound intersections. If we do the or case, then we're saying, because that's the greater, so less than greater, you're saying your distance is bigger than a certain thing. So you have two possibilities. If you're standing at x, if you say that it's greater than 2, you'd have to go 2 to the right and then say it's everything bigger than that. Or you could go 2 to the left and say it's everything smaller than that, because that would be a distance farther away from x than 2, or greater than 2 distance. So what we end up here is an or case. You have that your whatever your inside is, it could be x, it could be 5x minus 3. That argument inside is going to head towards negative infinity, which means we let it be less than the negative of our number, or it's going to be heading towards positive infinity, which would be greater than the positive of that number. So notice two very different setups depending on which one you're looking at. So if you're talking about it being a less than a positive, you're doing what I call the sandwich case. You're putting it in the middle. If you have the greater than distance, you want to go towards the infinities. So you have two separate cases. Now for this last piece right here, these are two special cases. an absolute value always comes out positive. So this just has to be, does this make sense or not? A positive can never be less than a negative, so this is always no solution. And again, you cannot determine that unless your absolute value is isolated first. And this one is always a positive. A positive is always greater than a negative, so this is actually all real numbers, which we would write as negative infinity to infinity. So now we're going to go through and we're going to solve some of these problems that I've picked out and make sure that we can get the correct answers for each of them. So this first type is an equation and it is isolated. So we set up that the argument is either going to be equal to the inside either could have been a -2 for the absolute value to be 2, or the inside could have been a +2. So when we add our 5, that would make this one 3. And if we add 5, that would make this one 7. So 7 minus 5 is +2, which the absolute value of that is 2. And 3 minus 5 is -2, and the absolute value of that is also +2. When we look at B, we notice that this one is not isolated, so we have to do some stuff first. So we're going to add 1 to both sides. So this will be 2, absolute value of 5x plus 2, absolute value, equals 6. By the way, you cannot distribute a number inside of an absolute value. It doesn't actually hurt anything if it's a positive number. It does make things go bad if it was a negative. So anytime we have a number out front, we always just divide it over. So this would be absolute value of 5x plus 2 equals 3. So notice that is a positive situation so that we can go ahead and try to solve this. So we would set up that either 5x plus 2 inside was a -3, or the case that 5x plus 2, the inside was a +3. So we would subtract 2 and divide and get -1 for this first answer. And then here we would subtract 2 and get 1/5. So -1 and 1/5. Okay, C1 is not isolated, so we need to subtract over that 5 first. Now this is a special case. We didn't go over this one, but if you have equal to 0, 0 is never positive or negative, so there's only one. If your distance is 0, your answer is just whatever makes the inside of the absolute value 0. So that is a special case. Let's put one else up here maybe really quick. Let's do -2 absolute value of x plus 1 equals 10. You'd have to divide by the -2 first. So this is just an extra. And we would get absolute value of x plus 1 equals -5. And remember, an absolute value cannot equal a negative, so this would be no solution. So that's pretty much all of the scenarios we would see for the equations. Now this next little grouping, these are going to be the inequalities. So the first thing we do is we check to make sure it's isolated, which this one is, and we ask which case is this? Is this the stuck in the middle or the two different infinities? And since it's less than, it's going to be stuck in the middle. So we write this as -7 is less than or equal to x less than or equal to 7. And then since the x is already by itself in the middle, there's nothing to solve here. So this would just be -7 to 7. My next one is a greater than case, so we have to set up the two cases. So we either say that the inside of this absolute value is less than -2. That's the case where you change the inequality and the number. That heads you towards negative infinity typically. But in this case, it's going to swap because of that negative in front of that x. And then the other case is you keep your absolute value the same and you go exactly the same with your two originals. So with the OR case, one case you just write everything as you see it. The other case you change the symbol and the sign on the right. So when we divide by -1, we're going to change some stuff though. This will become x is greater than 2, or this will be divide by -1, x is less than -2. So when we write that in interval notation, I'm going to always write the smaller one first. You go, this would be -infinity to -2 with a parentheses. This would be 2 to infinity, and the word or means that you union the gap together. You say that it's either this or this. Okay, let's look at C. So I would first isolate by adding over the 0.3, so that's going to be 0.4 over here. This is a greater than case, so we're either going to have x minus 3 is less than negative 0.4, or we could have x minus 3 is greater than 0.4. If we add 3 here, this would be x is less than 2.6. If we add 3 here, this would be x is greater than 3.4. In interval notation, that would be negative infinity to 2.6, unioned with 3.4 to infinity. Now, typically we would not leave answers in decimal format, but they started in decimals, so that's okay in that situation. Okay, let's look at D. I would add over my 2 first. And I actually think I want to, no, I don't want to change this one. This one's fine. So then we would add over that 2, so that's going to be 12. We would divide everything by 2. So that's going to be negative 11 minus 7x in absolute value is greater than 6. Since it's greater than, it's the OR case, so we have one case where we leave our inside the same, but we change everything else. So that'd be less than negative 6. Or the other case where we just keep everything as it is. I would add 11. So this is negative 7x is less than 5. Add 11. Negative 7x is greater than 17. Dividing by negative 7 will flip our inequalities, remember. And we're going to leave these as reduced fractions like they are. So this is going to be greater than negative 5/7 and less than negative 17 over 7. So in interval notation, that would be negative infinity to negative 17 over 7, since that's the less than case, and unioned with negative 5/7 to infinity. All right, we only have 2 more. This one, this is a special case. This is already isolated. This is less than a negative. A positive can never be less than a negative, so that would be no solution. If I change just the symbol in the middle to be greater than or equal to, I would immediately have to change this to all real numbers, because a positive absolute value will always be greater than a negative. So just make sure you pay attention that those two cases are different. And then the last one, this is it's a less than, so we're going to stick it in between, and it's got fractions. So this would be negative 1 is less than the 2x plus 5 over 3 less than 1. I would multiply everything by 3 to clear out that fraction. Subtract 5 all the way across all 3 sides, and then divide by 2. So this would be negative 4 is less than x is less than negative 1. So negative 4 to negative 1, both with parentheses. All right, that's the end of the video and what we would have covered in class today. I condensed it a little bit more so that it's easy to watch, hopefully, and I will see you guys on class on Wednesday.